from any of the quizzes or anything you came across on Canvas yet? Okay, you will see, you can just, if you want to start thinking about it, because our first exam's coming up next week, so that's a week from today, our first test. It'll cover chapters 2, 3, and 4, and then under the chapter 4 module, you can find the exam 1 module, and in there I just give a little information about what it covers. Then I also give you a practice test and then the solutions to that practice test. This is what you want to review along with maybe your quizzes as you're starting to think about preparing for the test, because that'll be most similar to what the exam will be like. So if you want to start looking at it over the weekend, you could do that. And then we're going to, by today, we'll have covered pretty much most of the material. And then next week we'll work a little more with fractions, solving equations with fractions, and then we'll just do some review for the test. So, okay? Questions? We all good? All right. So, let's do it. All right, so if you're trying to add and subtract fractions, there's a distinction you have to make, and if they have what we call common denominators, then it's really pretty easy. Okay. So we know that the denominator is the bottom number in a fraction, and so if you're trying to add fractions that have common denominators like 1/3 plus 4/3, something like that. Okay. Well, you got one of them, and then you're adding 4 of them. So how many of them do you have? You got 5 of them, and what are you adding? You're adding thirds. So with common denominators, meaning that they have the same denominator, then you could just add them up. Okay. So what would be the answer here? It'd be 5, and what were we adding? We were adding thirds. Okay. So it's really pretty easy when you have common denominators, because you just add the numerators or subtract the numerators, and then the denominator stays the same. So it's not like multiplication, which is straight across. You don't add the denominators. Okay? It's like the denominators are like the units, right? We're working in thirds. And so our answer should also be in thirds. All right? So, another example, you can throw negatives and positives into this. So like if we had like 2/5 plus like a negative 4/5. Okay. So first off, when I see something like this, anytime you see a plus and minus, what do I recommend doing? What do I tell you to do? Anytime you see plus and negative, what should it be? Yeah, it could just be rewritten as subtraction. It's a lot easier to handle it if you just take that initial step and just say, okay, I'm not going to deal with plus and minus. I know that this is just actually subtraction. And now, we're in fifths. And so if you have 2 of them and then you take away 4 of them, where are you going? Yeah, you're going negative, right? So 2 minus 4 is negative 2/5. All right. So far, so good? Okay. I'll just give you one more example. Let's say we had say negative 2/9 minus negative 5/9. Just to review some of our properties of like adding, subtracting negatives. So anytime you see a minus, what do you do? Yeah, you just immediately realize, okay, that's not really subtraction there at all, because when you minus a minus, it just becomes plus. All right? We're in ninths. So if you're at negative 2, and then you add 5, where is it going to take you? Positive. It takes you positive. Negative 2 plus 5 is 3. And then that's reducible. So remember, you should always reduce your fractions. 3 and 9 are both divisible by 3. So you'd want to reduce that one. This one is going to come out to be 1/3. Yeah? You guys feel pretty comfortable with that? Adding and subtracting fractions that have like denominators. So as long as they have the same denominator, it's really straightforward. It's just, you just add or subtract the numerators, the denominators don't change, and you might just have to pay some close attention to the signs, because sometimes negatives can give us problems, but the rules don't change for the addition and subtraction in the numerator. Okay, So what happens, though, when we get into unlike denominators? So like if I wanted to, for example, if I wanted to add, say, 1/2 and 1/3. Okay. So because before I showed you, the denominator is like your units. So when you added two fractions together, the unit and the denominator stayed the same, didn't change. But here we don't have like denominators. And so what denominator is going to end up, like what goes here, How do we handle that? Who knows?
You times the 2 by 3 and 3 by 2, you get 6?
Yeah, so what we basically have to do is, if you don't have common denominators, you have to force them to have common denominators. So basically, I have to manipulate them to turn them into common denominators. This is where that least common multiple stuff that we did back at the beginning comes in. Because basically, I need to bring these up. I can only go up because like 2's can't go lower, it's prime, and 3 can't go lower, it's prime. They're not reducible fractions. But what I can do is I could make them bigger. I can make my denominators bigger. And so we're going to take them up to the least common multiple, or what's called the least common denominator. Okay, so the least common denominator, which is, we'll just call it LCD. All right? And so what we're really looking for is the least common multiple of 2 and 3, which we know is 6. Okay? So what we need to do is we need to take 1/2 and 1/3, and we need to manipulate them a little bit. So then we're going to go, okay, so 1/2 plus 1/3, we need to basically give these a fraction to help them come up to 6. So what we're going to do is we're going to multiply them by a fraction that will allow that 2 to increase to 6 and that 3 to increase to 6. So like you mentioned it, if we want to get our 2 up to a 6, what do we need to multiply by? We got to multiply by 3, right? Now the thing is, though, is you can't just multiply the denominator by 3. Because if you just did the denominator by 3 and turn that into 1/6, 1/6 is not the same as 1/2. We're not trying to change the value of 1/2. We're just trying to make it look different. And so if I give the bottom a 3, I also need to give the top a 3. So you're going to multiply the denominator by whatever it takes to get it up to the LCD, and then you also have to multiply the numerator by the same number. Then we'll do the same thing for the next fraction. So in the denominator there's a 3, so what does this one need? This one needs a 2 in the denominator to bring it up to 6, which means we also, whatever you have to do to the bottom, you have to do to the top. So when we do that, well, what does this become, right? So it's straight across. So 1 times 3 is 3. 2 times 3 is 6. And over here, 1 times 2 is 2. 3 times 2 is 6. So now, both of those fractions are reducible, right? 3/6 and 2/6. Should you reduce them? No. We actually unreduced them on purpose, right? That was the whole point. So 3/6 is the same as 1/2, right? It's like the unreduced version of 1/2. And 2/6 is like an unreduced version of 1/3. But we unreduced them on purpose so that they share the common denominator. Now you can put them together, right? Because we're in sixths. So 3/6 plus 2/6 is 5/6, right? So this is the process you have to use when you're adding and subtracting fractions if they don't have common denominators. So you have to bring them up. You have to go up to the least common denominator by multiplying whatever number it takes to get there on the top and the bottom for every fraction. All right? Do you have any questions about that example? I'm going to do another one. Seem okay? All right, let's try another one. So let's say we had, say, 2/5 plus, I don't know, 3, let's go minus, actually. Let's do a subtraction. So let's say a minus 3/10. All right? So what's the LCD here? What's the least common denominator between 5 and 10? Well, so that's the greatest common divisor, but the thing is we can't bring this 10 down to 5. Because, yeah, to bring this 10 down to 5, we'd have to divide it by 2, but 3 is not divisible by 2. So when you're getting common denominators, you always have to go up. So, yeah, now you could go up to 20, but what could you also do? Yeah, 10 is actually, sometimes one of the fractions might already have the LCD. So 5 can be brought up to 10, so we don't need to bring 10 up higher. You could, it'll work. Like you can take them both up to 20, that would work. But we always want to try to go with the lowest numbers possible. So we're just going to have to manipulate that fraction. Okay. So then we say, all right, the LCD here is 10. So, whoa, that was cool. So what does 2/5 need to bring it up to a 10? So 5 times 2. So we're going to give it a 2 over 2, so that 5 will come up to a 10, and then we actually don't have to mess with this fraction because it already has the LCD. All right. So then what does this become? It becomes 2 times 2. This becomes 4/10. Yeah? And then the 3/10 we left alone, so it just stays 3/10. So now you got 4/10 minus 3/10. What does that become? 1/10. And that would be your solution. Okay. Now, the nice thing, well, before I say anything else about that, what questions do you have about that? You guys still okay with that? Okay. Now, the nice thing is, let's say you would have picked 20. Like you say, oh, I'm going to bring it up to 20. Which you could do. You'll still get the right answer. So if I decided I was going to bring these up to 20, so then like this one would need a 4 over 4, because that's what 5 would take to bring it up to 20. 10 would need a 2 over 2, right? So what you'd get is 8/20 minus 6/20. So that would be 2/20, but then what happens? 2/20 is reducible, right? These are both divisible by 2. And so what's that going to take you down to? It's still going to take you down to 1/10. So it's okay if you pick a common denominator that's not the LCD. It's just what's going to happen is when you finish your problem, you're going to end up with a reducible fraction. That's all. So, okay. Seems good? Okay. What if we throw in, let's go back. What if we throw in like a whole number or something? So what if it's like 2 minus 3/7? What should we do with that? Yeah. So just like with multiplication and division, anytime you get like whole numbers or mixed numbers thrown into a fraction expression and you want to simplify it, you want to take that whole number and rewrite it as a fraction. Right? So that whole number will be rewritten as 2 over 1. You got 3 over 7. Now what's the least common denominator here between 1 and 7? Yeah, remember you always have to go up, but these ones are actually not that bad because once you put it over 1, you just need to bring it up to whatever denominator is already there. So we'll bring these both up to 7s. So 2 over 1, it's going to need a what? Yeah, it'll need a 7 over 7. And 3/7 we don't have to touch because it already has that common denominator. Right? So then 2 over 1, when you multiply it by 7 over 7, what does it become? 14 over 7 minus 3 over 7. And then now we can do the subtraction. Oh yeah, I got ahead of myself. I'm thinking ahead. 7. Because 14 minus 3 is 11 over 7. So that'd be your solution. Okay. So that's an improper fraction, completely reasonable. If you wanted to turn it into a mixed number, how many times does 7 go into 11? Just once with 4 left over. Okay. You know, sometimes these whole number ones you can kind of figure out on your own because if you're taking away 3/7 from 2, 3/7 is smaller than 1. You know it's not going to go below 1. And how many sevenths are going to be left over when you take away 3 sevenths? Well, it's going to be, there's just going to be 4 sevenths left over. But anyways, converting them into impropers and working that way will always work. Okay. All right, questions on that one? Seem okay? Okay. So let's go with, how about if I had, say, 2/3 minus 1 and 1/10. So what if you start throwing in mixed numbers? Yeah, same thing. It's like, so this is it. When you run into fractions and you start seeing whole numbers thrown in or mixed numbers in there, you don't have to, it's not an issue. You just need to turn them back into fractions, basically. So the 2/3 I'll leave alone for now, but let's go ahead and turn this into an improper, right? So 10 times 1 is 10, add 1, what does this become? 11/10. Now we still have a problem because we can't actually, we can't actually add these or subtract these yet because we need to bring them up through the LCD. What is the LCD between 3 and 10? We're going to have to go up to 30. Okay, we'll have to go up to 30. So then we'll say, okay, so we're going to bring these both up to 30. Okay, so then what does 2/3 need to bring it up to 30? It needs a 10, so we're going to give it a 10 over 10. And then what does 11/10 need to bring it up to 30? Yeah, it needs a 3 to bring that 10 up to 30, so this one needs a 3 over 3. So far, so good? Okay. So then 2/3, when we give it the 10 over 10, that becomes what? 20 over 30, because you're multiplying straight across. Then 11 times 3 is 33 over 30. And then now that you've got your common denominator, you can just subtract. So you just do, well, what is 20 minus 33? It's negative 13 over 30. And you should check it to make sure it can't be reduced, but it can't because 13 is prime. And it's not an improper fraction, so it can't be turned into a mixed number. So that's it. That's all you can do. Seem reasonable? Everybody feel what questions do you have on this? Does everybody feel pretty confident with where all those numbers came from? Yeah, go ahead.
For like the exam, are we gonna have to do it to like the simplest?
For the exam, I don't really, I don't typically care that unless I specify. So if I specifically ask for like a mixed number, is that what you're asking about, like the forms?
For the answer, like.
Yeah.
Yeah.
Yeah, so unless I specifically ask for like, if I said specifically give me a mixed number, then I would want that.
Okay.
And then, but if I didn't say either way, if I don't specify, you can give it to me either form, I'll take it. Okay. So yeah, it's not that big of an issue, but if you don't simplify it though, then that's not okay. So like, for example, like if you gave me something like 10 over 4, like that would be not technically correct because it's not reduced, right? So I'd probably take off a point for that, but then if you gave me 5/2, that would be correct, or if you gave me 2 1/2, that would also be correct. So either of those would be correct, but 10/4 wouldn't because it's not reduced. Yeah.
I'm not sure if you're going to do this, but if it's subtraction and addition, does it matter? Like in the same, like if you do like for instance 2/3 minus, and then you add another fraction to it. Does it matter which order you do it in?
Yeah, it does. So when you have all addition and subtraction, so I could show you one. What's the rule? So like let's say we had like 1/2 minus say 2/3 plus 5, I don't know, let's go with 9ths or something like that, I don't know, right? So they're all different. First off, we're going to have to deal with that. But does it matter what order we do this in? Sort of. What should we do? Which one would you do first? Yeah, so when it comes down to addition and subtraction, it's all just left to right. Yeah. Question? No? Because, see, that's the thing that, and I may have mentioned it before, but that's the thing, and I was talking a little bit about yesterday, is that a lot of people, they really want to always add before subtract just because it comes on top. But these are actually these are kind of like the same level. So really, and these are also kind of on the same level. And so we just go left to right on multiplication, division, and addition, subtraction. It's not like one gives more precedent than the other. And the reason, this is what I was talking about yesterday, is because subtraction is not really its own operation. Subtraction is just addition of negative numbers. So, and then division is actually the same operation as multiplication. Division is just multiplication of fractions. So dividing by 2 is the same as multiplying by 1/2. So they're on the same level, actually. So in here, even though A comes on top, we wouldn't do this addition first. We would just work it left to right. If you did have multiple fractions in an expression, then you can do it two ways. You could just get the common denominator for the first two and combine them and then do LCD again. Or you could just go ahead and try to get the LCD for everything. That would also work. So like here, if we're going the LCD between all three of those numbers, let's say we wanted to do them all at once. Well, what is the least common denominator of 2, 3, and 9?
18.
You're going to have to go up to 18. Yeah. Because 9 won't work because 2 can't be brought up to 18. 3 could be brought up to 9, but 2 can't, so we have to go up to 18. And again, if you're trying to find LCDs, you just always want to go by multiples of the big number. So I just go up by multiples of 9 until I found something that was also divisible by 3 and 2. You just happen to hit it pretty quick here. You hit it at 18. Okay, so our LCD here would be 18. So then I would go ahead and bring them all up. So what is 1/2 going to need?
9.
A 9 over 9. That's how you'll get it up to 18ths. And then what does 2/3 need to bring it up to 18? 3 times 6. This one needs a 6 over 6. And then what does 5/9 need? 9 needs a 2. So it needs a 2 over 2. Okay. All right. So then now 1 times 9, this will become 9/18. 2 times 6, this would become 12/18. And then 5 times 2, this would become 10/18. Right? And it looks weird because it's a bunch of reducible fractions, but we've made them reducible fractions on purpose. We brought them up so we can get that common denominator. Now you just go straight across. So you start here. So 9 minus 12 gives you what? Negative 3/18. Then you would add your 10/18. So if you're at minus 3 and you add 10, where are you going? You want a positive 7. So then the answer here would be 7/18. You should always check to make sure it's reducible, but this one's not, because 7 is prime. And 18 is not divisible by 7. So. All right. What questions, Yana? All good? Seems pretty straightforward? Fractions aren't that bad. They really aren't. I think it's just, I don't know why they're so difficult for a lot of people. They're tedious, it's true. And I think a lot of people don't get enough practice with them. I think just when they're younger, and then you get into higher classes and your teachers are like, you should already know this. And then it's like, yeah, it's just a mess. But they're not that bad. Okay. I'll do one more, and then I'm going to let you guys do some practice. So let's say we had one where we had, say, 2 and 2 ninths minus a negative, say, 3 and 1, 15th. So there's a few things going on here. The first thing I see that bothers, this is me personally, the first thing I see that bothers me personally about this is, what do you think it is? Yeah, it's the minus a minus. I just don't like dealing with that. It just makes things more confusing than it needs to be. And so if you're doing minus a minus, what should I rewrite that as? Plus. So that's always my first step. Before I go to impropers, before I go common denominators, the first thing I do is I just rewrite that minus a minus as a plus. Then we can move on. So, now, what should you do?
Change out
Yeah, mixed numbers are a mess. Okay? They're not good for math, so we don't really leave them that way. So we need to convert. So 9 times 2 is 18. 18 plus 2 is, this becomes 29ths. All right? Then here, 15 times 3 is 45. 45 plus 1 is 46. The only downside of this is that some of these numbers are probably going to get kind of big, but that's okay. Now you have to figure out, well, what is the least common denominator between 9 and 15? It's going to be 45, yeah. And the easiest way to figure that out is you just go, okay, 15 is not divisible by 9. So you go 15 times 2 is 30. That's not divisible by 9. 15 times 3 is 45. That's divisible by 9. Okay? Is there another way you could do it? What's that? Yeah, you could. And then with the other, we learned the other, what was the other method we learned, right? You technically could do the prime factorizations. So if you get to denominators and you can't figure out what the LCD is, you can always fall back on the prime factors method, because 9 is 3 times 3 and 15 is 3 times 5. So the least common denominator, well, they both have a 3, and then there's an extra 3 and an extra 5 in there, right, that we have to clean up. 3 times 3 is 9 times 5 is 45. So you can always go back to that method if you're not sure. But either way, the answer here is, yeah, we need to bring this up to 45ths. Okay. All right. So what does 9 need to be brought up to 45ths? 9 times 5. So the first fraction will get a 5 over 5. That'll bring it up to 45ths. What does 15 need to bring it up to 45? 15 times. It's right here. 1, 2, 3. So this one needs a 3 over 3. Okay. And now our numbers are going to get a little bit big, and that's okay. We can deal with it. So 20 times 5, this is 145ths. 46 times 3, that's 138. Yeah? 138 45ths. And now you can combine them. So then what do you get if you combine those? Yeah, you get 238 45ths, which is great. That's an awesome number, I guess. It's actually right. It's technically correct. We know what 45 is divisible by. It's divisible by 3 and 5. So you can check to see if 238 was divisible. I know it's not divisible by 5. I don't think it's divisible by 3. So this actually can't be reduced. So that's actually not the wrong answer. That is correct. Now that's just a really weird way of describing something to someone. So if you wanted to convert it to a mixed number, what do you got to do? You pull out your calculator and see, because what is 238 divided by 45? 5.288. It's like 5 and some change, right? If you wanted to turn it into a mixed number, you have to just figure out what the remainder is, right? So it looks like 45 goes into 238 5 times. Okay, well 5 times 45 is what? 225. And then you can figure out your remainder. 8 minus 5 is 3. 3 minus 2 is 1. So it looks like the remainder is 1345. So that was a little bit messy, but yeah. So it's just remember the steps. If you see negative numbers in there, deal with that first. Then turn them into their impropers. Then you can deal with the LCD. If the least common denominator is a little bit complicated, you could always fall back on prime factorizations to figure out what it has to be, or you can just do guess and check, and then from there it's just finishing it off. Okay? All right. What time is it? 12 o'clock? All right, so I've got this today. You guys aren't going to I don't think you're going to have time to finish this today. So probably what I'll do is I'll just let you work on this today, or you can take it home and then I'm going to go over the answers to this one at the beginning of class on Monday. But try, if you don't get them all done today, or you don't stick around to do it today, try to work on them over the weekend, so that when you come back, it's not like all fresh. It's good to get some practice while it's in your mind. And I think that's all I got for today. So, if you don't want to stick around, you don't have to, but you're welcome. Ask questions, give it a try. Let me stop my recording real quick, and then I'll pull that example back up so you can see it.